This topic is we're going to talk about triangles and how to classify them by angles and sides. So again, it's lots of formatting that you need to make sure that you're following. A triangle is a polygon with 3 sides and 3 angles. And on the triangle to the left, the sides, now remember, these are points, so they have to be uppercase letters. Don't tell me it's lowercase. It's not, because uppercase represents points in geometry. So if I had to label these, the sides are YZ, and it's a side. So you must have that mark, ZX, and XY. All uppercase and all have that segment above. The angles are angle X, angle Y, and angle Z. Okay? Now, the triangle sum theory states that the sum of the measures of the 3 angles is always 180 degrees. So I know, if I made a statement, that the measurement of angle X plus the measurement of angle Y plus the measurement of angle Z, all of these added up is going to equal 180 degrees. So, and we know that. We talked about that before. Triangles have 180 degrees. So if you had to find the missing measurement, I'm just going to do a couple of these. How would you do this? Well, you know that X plus 79 plus 82 all equals 180 degrees. All of these guys added up, sum, addition. So I know that X plus 161 equals 180. If I subtract 161, I know that X equals 19. And then it just wants me to find X, so I don't need to go back and do anything. I know that X is 19 degrees. Okay, let's look at number 3. We know this value is 90. So I know that 90 plus 53 plus X all equals 180. So 143 plus X equals 180. Of course, you subtract by 143. And I know that X equals 37 degrees. So that part, easy breezy, you know it. Let's take a look at number 8. So we've got a little algebra, but I'm still following the same rule. Add them all up, and you get 180 degrees. So 5x plus 1 plus 14x plus 4x minus 5 all equals 180 degrees. I don't need that mark for fun. And so now I have 19 and 4 is 23x minus 4 equals 180. Add 4 to both sides. 23x equals 184. And divide by 23, and I think x is going to be 7 or 8. It's going to be 8, so x equals 8. I don't need to go back and plug in, but if it asks me for that specific measurement, I would. It's just asking me to solve for x. Okay, and that's what number 9, I should have done number 9. That's what number 9 is doing. Add them all up and then go back and plug in. But let's talk about the types of triangles. So you name a triangle by its side and its angle. We've already done the angles. We already know all acute angles. These guys are going to be all angles. All angles are less than 90 degrees. In an obtuse triangle, one angle is greater than 90 degrees. And then in a right triangle, you know that one angle is equal to 90 degrees. So it's like the types of angles that we've talked about. Same thing for triangles. Okay, so acute, all angles are less than 90. Obtuse, one angle is greater than 90, and then in a right triangle, of course, one angle is 90. Now, on this right triangle, this side opposite the angle is called your hypotenuse, and it is always the longest side. Okay, that's a hint for what's to come later, but that's a very special type of triangle. Now, when you classify triangle by sides, here's what I like to think about. How many lines are parallel in the letter S? No. So a scalene triangle has no congruent sides. And this is what the marking looks like for scalene. These tick marks represent congruency. And since they're all different, they all have different measurements. So a scalene has no sides that are congruent. So this is a scalene triangle. An isosceles triangle, look at the letter I. Two lines are parallel. So in an isosceles triangle, you have two lines that are congruent to each other. So isosceles has two sides that are congruent. And if you look at the letter E, how many lines are parallel? 3. So in an equilateral triangle, all sides are congruent. So the letter E, all of them are congruent. The letter I, two sides, isosceles, and scalene is no sides are congruent to each other. So we classify triangles by sides and angles. So if you look at number 10, if I classify by its sides, two sides, I know it's isosceles, and I know it's a right triangle, so it's a right isosceles triangle. Number 11, these all add up to 60 degrees, so this is an acute, because they're all less than 90, equilateral, because they're all equal to each other. And this one, if this is 41 and this is 22, I first need to make sure this is 117 degrees. And so no sides are the same. There's no tick marks, and they're all different angle measurements. That one's greater than 90, so it is an obtuse scaling. Here, you've got two lines that are congruent. These are all less than 90 degrees, so this is an acute isosceles triangle. All right, look at number 14. 31, 31, that's 62, so this guy is 118. These sides are equal to each other, so I know it's two sides, so isosceles, obtuse. Okay, now, here, if it's telling you you have a triangle, draw a picture, it makes it easier. JKL, so J is 5x minus 3, K is 11x plus 13, and L is 9x minus 5. So on this one, first we have to know what degrees we're talking about. So we're going to add them all up, and they all add up to 180. You don't need me for this, so combining like terms, I'm going to subtract 5 on both sides. X equals 4, 7. All right, so I know here that the value of x is 7. But now I have to classify by its angles. So I'm going to go back and I'm going to plug in 7. 5 times 7 minus 3. 35 minus 3 is 32 degrees. That guy's 32. 9 times 7 minus 5. That's 63 minus 5. That's, excuse me, 58 degrees. And then 11 times 7 plus 13 is 77 plus 13. And that is 90. Now, clearly, my picture does not match my triangle, but it gives me something to go off of. So I've got 58, 32, and 90. So I know it's going to be a right triangle. Right? So that's how you do triangles, angles, and classifying. Come see me if you need some help.